Okay, so good evening, guys. It's been a long time, and actually, it's my third attempt at making this particular video. Now, the reason for me making this particular video is just the amount of people reaching out on DMs with an intent of moving away from VMware. And one of the core technologies, or one of the core reasons they want to move away, is because of something called Nutanix, right? So that's the reason I decided to actually make this series of videos as to explaining what exactly Nutanix is in easy to understand format, and take it on from there. So this particular session, this first video is just going to be a brief overview of Nutanix, and then we will kind of talk about some of the details as to how Nutanix works. Now, the first question that comes up is, what exactly is Nutanix, right? How does it work? So, Nutanix, like all of the vendors actually of HCI infrastructure, by now there are a lot of companies doing the same thing. But then HCI, it's actually called Hyperconverged Infrastructure. So what does this hyperconverged infrastructure actually mean? So traditionally, let's say I had a set of 3 nodes. So nodes in this case might be servers. So you have HP, Dell, Lenovo, right? Any of these guys. So in a 3-tier architecture, essentially what you had is 3 servers, which would actually talk over some kind of a fabric or a network. And then it'll actually talk to either a NAS or a SAN. So NAS is actually your network address, network storage, and your SAN is obviously your SAN storage. So that's actually iSCSI or your fiber channel. Now, network attached storage is essentially NFS. Right, so generally we call this as a NAS. So how this used to work is, for example, let's say we have ESXi as our base install, this of course as the hardware, and we wanted to create some virtual machines. We would actually carve out a LUN or create an export. So essentially what we would have is we'd have to mount this LUN in all of these systems or all of these nodes and create something called a data store. So what is data store? Data store is essentially the place where your virtual machine files actually reside, right? So this is your typical 3-tier architecture. Now what Nutanix is essentially this. So let's say we remove all of this, click on a pencil again. So let's say we have got these 3 nodes which are here. Now what does a typical node have? Of course it will be having CPU, it will be having memory, and it will also be having some kind of storage. Now let's say that these devices or these nodes, again from any other vendor, it doesn't matter, actually has a collection of hard drives, SSDs and NVMEs, right? So these are per node. So you have some disks here, and some disks actually here. Now what Nutanix does is, when you want to install Nutanix on these 3 nodes, you will have to install first the hypervisor layer. So essentially this is going to be like an ESXi install, but then the storage devices which are local to the node, you don't allow the ESXi or the hypervisor to take control of those devices. Instead what you do is you kind of create a virtual machine per node. So you'll be having one VM here, one VM here, one particular VM here. And the reason for these VMs is that you can actually pass through the storage controller across to this node. So what that does is, for example, this node, once it boots up with ESXi, it'll figure out that it doesn't actually have any storage devices. But then the VM, it will have access to the storage devices or the set of hard drives and SSDs and NVMEs. Now, of course, we know that we've installed ESXi, let's say, on these 3 nodes. So that's your hypervisor layer. What we'll do inside the CVM is we'll actually install a custom operating system called AOS. So what is this AOS? It's actually called Acropolis OS or Acropolis operating system. And this is a customized version of CentOS or Rocky Linux, depending upon which version you are looking at. And what this actually does is these VMs sort of talk to each other, and they'll actually aggregate storage. So what that means is, for example, let's say I have a total of 1 gig storage, including hard drives, SSDs, and VMEs on this node. So it'll actually aggregate the storage on all the nodes. So if you have 1 gig here, 1 gig here, and 1 gig here, essentially you're going to have an aggregate of 3 GB of usable storage on these particular nodes. Now, how do we do that? We actually create an NFS namespace, and we sort of aggregate all of these storage together. And the way we do this is we create this aggregate called a storage pool, right? So in simpler terms, if I were to wipe all of these out, let's say, just for me to draw the figure a little better so that it's easy to understand, let's get the pencil. Okay, so this is how things actually operate, right? You have these 3 nodes which are here, and you also have these 3 CVMs which are running on these nodes. Now the first question is, if all the disks actually pass through to the CVM, by the way, the virtual machine that you create is actually called a controller VM or a CVM. So the first question is, if all the disks actually pass through to the CVM, where are we installing the hypervisor? So the hypervisor would actually have a flash device, which would either be an M2 device or it will be a SATA DOM. So both of these are actually flash devices, and these are small in size, so it can be around 64 GBs in size. And when we install the hypervisor, so for example, if we were to install hypervisor, so we have a choice when we install either ESXi or we can actually install Hyper-V, or we can install Citrix, or we can actually install something called AHV, right? So all of these, whichever hypervisor we choose, is going to be installed on this SATA DOM partition. So the base partition for the hypervisor install is this one. So what are those hypervisors that we support? We support ESXi, yes. We support Hyper-V, Citrix, and of course something called AHV. Now, what exactly is AHV? AHV is called the Acropolis hypervisor, and what this is again, it's actually a customized CentOS / Rocky install, depending upon which version you are installing. So what differentiates the hypervisor from the CVM? The hypervisor, of course, it actually runs a process called Chemo, and Liberty, which actually works in tandem for us to create virtual machines. So the AHV is actually a customized KVM sort of a framework that we are running on each of these hosts. Right? So this is what the Acropolis hypervisor actually is. Now, how does all of this work? So for example, let's say I have let's say I have one node, for instance, here. So wherein I know that I have got my SATA DOM, and let's say the hypervisor I'm using is actually ESXi. ESXi is installed here. Now if you look at the ESXi vSwitch, or a virtual switch, a standard vSwitch, a standard vSwitch sort of looks like this. So it will be having a PNIC 1 and a PNIC 2. Of course, there's also a VM kernel port here, VMK0, let's say this one. And of course, you have your port groups on this side. And let's say one of the port groups, you actually have the CVM connected. Right? So this is typically how a standard switch looks like. Now, there are a couple of things which we do with a VM kernel port. So for example, if you have a VMK0, generally that's management. We can also have another port, VMK1, which we can create for things like iSCSI. So you can actually create multiple VM kernel ports depending upon your use case, right, for the environment. In our case, what we'll do is, for this switch that we have, now this will be called vSwitch 0 because it's the default switch. We'll also have something called vSwitch internal, and there'll be one more vSwitch which we create here, right? So what this is actually a vSwitch with no uplinks. So this doesn't actually have any uplinks. And the way we do this is we'll have one of the CVM interfaces here and one of the VM kernel ports here. So that'll be generally VM kernel 1. And so the IP address, this vSwitch 0, because it's management, this will be having a public IP. So things like your 10.112.x.x. So whatever your IP address range is. But this vSwitch internal, essentially for the host, for the VMK1, it'll be having 192.168.5.1, and for the CVM, it'll be having 192.168.5.2. Right? So these are the two range of IPs it has. Now, apart from these two ranges of IPs which the host and the CVM has, the CVM also has a public IP. So that can be in the range of, again, 10.112.x.x. So in other words, if you look at the host, it'll be having two sets of IP. One is a public and one is a private. And if you look at the CVM also has two sets of IPs. The first IP is, of course, the public IP, and the second IP will be the private IP. Public IP can be anything. When it comes to the private IPs, it's 192.168.5.1 and 192.168.5.2. Now, all of the hosts in the cluster, for example, let's say you have 3 sets of hosts of the same configuration. In that case, all the 3 hosts for this internal interface is going to have the same set of IP addresses for the host and the CVM. And the reason this works is because it doesn't actually have an uplink at all just a standard interface. And so any traffic which is coming from the host on this particular IP range will just be handled by the VM kernel itself, right? From the VM kernel, it will be pushed on to the controller virtual machine. So that's how it operates. Now, let's get this cleaned off again. Let's say I have 3 nodes, A, B, and C. And now we know that there's going to be a CVM somewhere here. We also know that there's going to be some disks which each of the CVM can see. We also now know that there's going to be an NFS namespace which is actually created. Now on the ESXi host, what is going to happen is we will be taking the storage from individual CVMs and we'll actually be mounting them to the individual host. So for example, if you look at this NFS space, this contiguous region here, we're going to be mounting it on each of the 3 nodes in the form of a data store. We can call it a data store 1 or something. Now the way that we mount it is actually by using NFS. So the ESXi host, all the 3 hosts will be seeing a data store, an NFS data store. And the way the data store is created is, from a CVM perspective, there are 2 things which happen, right? The first is it aggregates all of the storage across different nodes and it creates the first layer called a storage pool. So what a storage pool is actually an amalgamation of all the nodes, or rather not all the nodes, but all the disks that each of these nodes have. And so if you have, for example, 1 gig here, 1 gig here, and 1 gig here, the total size of your storage pool is going to be around 3 gigs in size. Now apart from that, let's say now I start creating my virtual machines. So instead of dumping all my virtual machines in one storage pool, what we generally allow, or what we generally do, is we allow the creation of something called containers. Now what are containers? As the name suggests, right? Containers are just buckets which contain or which hold the VM virtual machine files. So for example, on the ESX side of things, if I create a VM called VM, so it will be having files vm.vmx, vm.vmdk, etc., vmflat.vmdk and all that. All of these files which it contains, creates, will sit on these containers. Now why do we actually create a container? Why can't we just dump everything on the storage pool? Creating containers allow us to do a couple of different things. One is it allows you to use different storage savings technology. So for example, in one container, let's say you want to enable things like compression. On the other container, you want to enable things like dedupe. On the third container, let's say you want to enable ECX, or a combination, of course. So separate containers allow you to do that. Now why do we need to do this? It actually depends upon the workload that you have. So for example, let's say you have all your virtual machines are VDI environments or virtual desktop environments. Of course, this pool, VDI pool, will be created from a golden image somewhere. So chances are that all of your virtual machines are almost similar, right? Unless they have persistent data. But anyway, even if they have persistent data, chances are that the majority of the virtual machine image would be exactly the same. If that's the case, in that case, what we'll need to do is we need to actually enable dedupe on this particular container. So what dedupe will do is it'll go ahead and check the checksums of all the files that a virtual machine actually has. And if it finds that the checksum of two of the files from two of the images are exactly, or virtual machines in this case, are the same, it knows that it's actually the same file, so just keep one copy of that. Right? So that gives you space savings that way. Now, the other thing that we need to keep in mind is what happens when a node fails, because remember, we are actually running on local storage here. So whatever data the VM is writing is actually going into this, or rather these set of disks which are here. So if you have a situation wherein this node goes down, in that case the virtual machine might not be recoverable. Now, to prevent that from happening, what we actually have is something called replication factor. Replication factor. Now, what is replication factor? Replication factor actually allows you to set the number of copies of data that you have on your cluster. So generally, we can have RF2, RF3, and in rare cases, RF1. So what does this particular value actually mean? So generally what we generally use in production is RF2 and RF3. So if you have RF2, in that case, apart from writing a copy of the data on the local node, we will randomly write a copy of the data in one of the remote nodes as well. So how that helps is, if one node goes down, a copy of the data still survives in either one of these nodes. And so when HA triggers, for example, when VMware HA triggers and the virtual machine comes back on one of the surviving hosts, is able to power on just fine, because a copy of the data will be either in this node or in this node. So for that to work, there's a couple of things which need to happen, right? So all of these CVMs will need to work in tandem. So whatever read writes are happening, so all of these nodes or all of these CVMs should be able to predict as to which nodes are holding what sort of a data and replicate the data as needed. And for doing that, what we have are services which are installed within each CVM, which actually does it automatically for us. So what are some of the services which each of these guys have? So let's just remove this. Now when we say that there's a read or a write operation coming into the cluster, and when we say that we actually have an IP address 192.168.5.2 that the CVM has, there's actually a service which is responsible for handling IOs which are coming in or which are being requested by the VM, and that particular service is called Stargate. The Stargate, essentially what it does is, it's a distributed sort of a workflow wherein each IO which is coming onto the environment or to this specific node, it'll go ahead and start writing the data on the local node, as well as replicate a copy of the data on the remote node. So how does it figure out as to how many nodes there are in this cluster? That is done by a particular process called Zookeeper. So Zookeeper is a NoSQL database which contains configuration aspects of the cluster. And so when we have a cluster of 3 nodes, essentially what we are doing is we're actually creating 3 Zookeeper nodes on a cluster, and having a cluster which actually each of these nodes are aware that there are 2 other nodes in the cluster. Now apart from this, What we also have are other processes. So for example, you have Curator, you have Cassandra, right? So these are the other tools that we have, or the services that we have. And some of the things that they do, of course, we also have other services, but these are the primary ones when you are doing a read and a write operation. So in other words, a collection of these services, what it does is it kind of allows the system to build a multi-node cluster wherein each node is responsible for some of the operations that each of the node does. It's also responsible for data resiliency. It's also responsible for ensuring that there are no outages. So this, in short, is how the Nutanix cluster actually operates. Okay. So this is the first in a series of sessions which have been requested. In case you find this interesting, like, subscribe, share, comment, and also DM and let me know what you want me to make videos on in future. So thanking you all for watching this particular video. Thanks a lot and good night.